Hello everyone, and welcome to another Khan Academy tutorial. All you algebra students or advanced topic students or algebra 2 students, welcome to probably problems that you're not very comfortable doing, which are word problems, and not only that, system of equation word problems. But I'm going to try to break it down and make it as easy as possible, so just bear with me for the next couple of minutes, and we'll see how we do. A stone fell off from the top of a cliff into the ocean. In the air, it had an average speed of 16 meters a second. In the water, it had an average speed of 3 meters per second before hitting the seabed. The total distance from the top of the cliff to the seabed is 127 meters, and the stone's entire fall took 12 seconds. How long did the stone fall in the air, and how long did it fall in the water? All right, lots to break down here. Keep in mind that with systems of equations, we essentially are going to be looking for one equation and two equations with two variables. Two equations, two variables, x and y. We'll need to define our variables first. One of the first things we need to do is understand what are the variables. What should we define them as? If we're looking for seconds, then let's let x equal the time in the air. And then we'll let y, let's make it red, I suppose, or whatever color this is. Y will equal the time in the water, in the H2O. Okay, so time in the air, time in the water. Our first equation could be very simple. It could just be this then. Number one, x plus y, the time in the air and the time in the water, will be the total time. And the stone's entire fall took 12 seconds. So we know this is equal to 12. So that's our first equation. Obviously, it doesn't do us any good to just have that one, so we need another equation. The other information it gives us is we have this 16 meters per second and 3 meters per second, and then it gives us a distance. Okay? One of the things I want you to recognize is that these two things are rates. They're a speed. Anytime you have a speed with a divide, something per something, that is a rate. So miles per hour is a rate. Meters per second is a rate. Now, what is rate equal to? Rate is, as it shows here in this little spot, m over s, is distance divided by time. Well, that's great, that's all good and all, but it gives us a distance to work with. It doesn't give us another rate to work with, it gives us a distance. So what we need to do is we need to find our rates in terms of distance. Okay? We already know something else. We already know that this is the rate in the air. Okay? So if we're going to break this down into the air rate, okay, our air rate is 16 meters per second. And then we have our water rate, and that's 3 meters. Obviously, it goes slower in the water. Okay. But now, how do we calculate the air distance? Because that's really what we want to know. We want to know if this fell through the air. Okay, so it fell through the air, and then it plops in the water. Okay, my water's purple. Bear with me. And then it goes through the water. Okay, what is that total distance? So we want the air distance. Oops, I don't want that color. I want the green. I want the air distance, air D, and I want the water distance, H2O. I should have made water blue. Missed opportunity. Okay, how do we find the distance? Well, if we know that 16 meters per second is the rate, we can do a little bit of manipulation here to find the distance. Well, how do we solve for distance here? And this is what you have to do a lot. Anytime you get an algebra 2 or physics, you want to do a lot. Is we want to solve for distance, so we're going to multiply both sides by t. So now we know that time times the rate is equal to the distance. This is very much an SAT type thing to do, by the way. So distance equals time times the rate. Well, we know what that is for both of these. Okay, we know what it is for both of these. We know what our rate is. That's 16, and we know what our time is. That's x. We just took our time in the air, multiplied by x. Okay, that's good. We can do that because we've already established that as a variable, and we're just going to do the same thing for the water. So our rate is 3, up here 3, and our time is y. So we multiply the rate times the time, and we'll figure out the distance. So this distance is 3y. This distance is 16x, and now we have our second equation. We know that 16x plus 3y equals a grand total of 127. Okay, at this point, we have it set. We have everything established. Now, this is where, that's probably the toughest part. So now it gets to the part where you probably do all this drill and kill up in class, where you do 1,000 of these problems. And this is where your substitution elimination comes in handy. In this case, it's looking to me like I kind of want to do some elimination. So what I'm going to do is I'm going to multiply this top equation by -3. I'm going to write that result down here. Negative 3x minus 3y equals negative 36. So now the whole point is I add these two together, and I have 16 plus negative 3x gives me 13x. Okay, and then I have 3y plus a negative 3y, or if you want, 3y minus 3y. And of course, the whole reason we chose that to multiply negative 3 is so that I could eliminate the y's. That's why it's called elimination. So I eliminate the y's, and I get plus 0. You don't even need to write that, though. And now I have 127 minus 36, and I get 91. So now I have 13x equals 91. I need to divide both sides by 13, and I get x equals 7. Okay? Now, once we have this, x equals 7, if it fell for a total of, that was the time in the air, so I should write that in green. So x equals 7. This fell for 7 seconds in the air, and now we can just plug it into this top equation up here. So I know that 7 plus y equals 12. Well, obviously it's going to be 5. We subtract 7 from both sides. Minus 7, and we get y equals 5. So it fell in the water for 5 seconds. So we're going to go ahead and write that in. Fell in the air for 7 seconds. Fell in the water for 5 seconds. Check it out. There we go. Next question. Okay, Malcolm and Ravi. This might be the last one we do, just to give you an idea. Again, we have rates. I'm just looking at it right away, and I see that we have rates. Malcolm and Ravi raced each other. The average of their maximum speeds was 260 kilometers an hour. If doubled, Malcolm's maximum speed would be 80 kilometers an hour, more than Ravi's maximum speed. Okay. If doubled, Malcolm's maximum speed. Now, I'm just curious if that means they're doubling both of those. Oh, I think that means. What were Malcolm and Ravi's maximum speeds? Okay, this one's a little bit easier than the other one, I think. Okay, so let's define our variables. So we want to find the maximum speed. So we can let, I'm going to let m equal Malcolm's speed. Okay, and I'm going to let r, let's use, I don't know, red, equals Ravi's speed. I forgot the apostrophe. Sorry. English is important. Capital letters. There we go. Okay, so we have m equals Malcolm's speed and r equals Ravi's speed. So the average of their maximum speeds was 200 kilometers an hour. Now, we need to understand what average means here. The average of their maximum speeds, average is when you add the two speeds together, so speed 1 plus speed 2, and you divide it by 2. That's equal to the average. You can do that with age, you can do that with anything, okay? So average is when you add the two together and divide by 2. So we already know that m represents the first speed, the maximum speed. R represents Ravi's speed. So if we divide that by 2, the average is 260. Okay? Now, I don't know about you, but I'm not a big fan of having fractions in our problem. So what I'm going to do is I'm going to multiply both sides by 2 to get rid of this fraction. That way I can get rid of that, and I get m plus r equals 520, right? Yeah. 260. What color am I using? Okay. So, no, not 260. I just said this. 520. All right. We have one equation. We're good, okay? But we have two variables. We need a second equation. If doubled, Malcolm's maximum speed would be 80 kilometers more than Ravi's maximum speed. Okay, so now we have speed. We have to double Malcolm's speed. I don't think it means that we double Ravi's speed. I'm pretty sure if doubled, Malcolm's maximum speed. So we double Malcolm's speed, and it would be equal to 80 more than Ravi's maximum speed. So we're actually going to give some space. These can kind of trip some people up. Anytime you say 80 more, some people get a little confused. So here's Ravi's maximum speed. If we double Malcolm's speed, we still have to add 80 to Ravi's speed to equal double of Malcolm's speed. Okay, so again, 80 more, that's plus 80 than Ravi's speed. 80 more than Ravi's speed is written like this. Double Malcolm's speed is written like that. I'm just hoping this double doesn't apply to both. I'm just interpreting what they wrote. Hopefully the English works. This is my caveat just in case it's wrong. Okay, so in this case, it's probably going to be easier to use substitution. So what I'm going to do is I'm going to get it in terms of R. So I'm going to subtract 80 from both sides. Minus 80, minus 80. So then I get 2m minus 80 equals R. I'm going to use red still. Now, what am I going to do with that? I'm going to plug this into the other equation and then solve. So now that I have it all in terms of m. So I have m, and I'm going to write right over the problem here, sorry. M plus 2m minus 80 equals 520. Combine like terms. We have 3m minus 80 equals 520. We're going to add 80 both sides. We have add 80, sorry, a little small. 3m equals 600, and we're going to divide by 3, and we get m equals 200 kilometers per hour. That's Malcolm's speed. So Malcolm's speed is 200. Okay, that's our first step. Now, once you have one of your variables in any system of equations problem, once you have one of your equations in terms of a number, we can plug that into either equation. In this case, it makes a little bit more sense to plug it in this one. This looks pretty easy. 200 plus r equals 520. I subtract 200 from both sides, and I get r equals 320. R equals 320. And we could check our answer by plugging it back in to the original problem, but you're going to see that it's going to work out, given that we're not doubling the other speed. And I think this works. These are pretty neat numbers, so I'm guessing it's right. So Ravi 320, Malcolm 200. Malcolm 200, Ravi 320. And show me the money. All right. Hopefully you found this video helpful. Again, with rates, make sure you find it r equals d over t, and then you need two equations, two variables. Hope you enjoyed this video. See you next time on Wes Explains.